In this lesson, we're going to explore the best method to use for systems of equations. Now that we've learned all three methods of graphing, substitution, and elimination, it's now time to look at when is it best to use each of the three. So it's best to use graphing when you just need to estimate an answer, when the equations are both in slope-intercept form and they're easy to graph, or when you're just needing to identify if it's one solution, infinite, or no solution. Graphing is going to be the best way to do that. When you need a more exact answer, and one of the equations has a variable that's by itself already, or the equation's easy to solve for a variable by itself, then substitution is going to be the method that you want to use. If it can be easily changed to slope-intercept form, remember that you can use substitution, especially if those equations are harder to graph, because you could set them equal to each other and solve that way. And then elimination is going to be best when both equations are in standard form and when the coefficients are easy to eliminate if one is opposite of the other. So you're looking for those equations to be in standard form. That's going to be elimination would be the best method to use there. So let's look at the following. Now, on our examples, I'm going to clarify that we're not going to solve using all three methods. I'm just going to kind of show you which method would be the best for each of the examples that we're doing. So in this first one, we have x equals 4 minus 3y, and 2x minus 6y is equal to 8. Now, the best method to solve this system would be to use substitution, and it's because this x is already solved and it's already by itself. So I can substitute it into my second equation. So instead of 2x minus 6y, equals 8, what I can do is I can plug in 4 minus 3y in for that x. So I'd have 2 times 4 minus 3y. Then distribute, so this would be 8 minus 6y minus 6y is equal to 8. Combine like terms, so that would be 8 minus 12y is equal to 8. Subtract 8 on both sides, that would be negative 12y is equal to 0. So then that would mean that y is equal to 0. Now that I know that y is equal to 0, I can plug this into either of the original equations. So I'm going to just pick the top one. I'm going to plug in 0 for y, since that's what y is. That's 4 minus 3 times 0, or 4 minus 0. So that means x is equal to 4. So the solution for this first one was 4, 0. Again, I know the best method is substitution from this one, because this is what requires the least amount of changes to my original equation. Now, the second set is going to be best to solve using elimination, because both of these equations are in standard form, and if you haven't already seen it, 6y and negative 6y are opposites of each other, and so they'll cancel out when we eliminate. So as I do elimination, I know the y's are going to eliminate, they're going to go away. I'm combining everything else, so 4x plus 3x gives me 7x. 32 plus 33 or plus 3 gives me 35. So 7x equals 35, x equals 5. And now that I know that x is equal to 5, I can plug that into either of the original equations. So I'm picking the top one. That's going to give me 20 plus 6y is equal to 32. 6y is equal to 12 when I subtract 20 on both sides. That means y is equal to 2. And so my solution here is 5, 2. X being 5 and the y being 2. Looking at this third one, this one would be best to solve using graphing. The reason why I would choose graphing for this one is because both of these equations are fairly easy to get into slope-intercept form, even though they're not already there yet. On this top one, I would just have to divide everything by 2 so that y is by itself. This would be y is equal to 2x. On my bottom one, I would just need to add 2x to both sides to get y by itself. So y is equal to 2x minus 2. So again, I'm only having to do one thing to each of these equations to get it into slope-intercept form, and then I can graph them. So for my top one, that says start at the origin, and then it has a slope of 2, so go up 2 and right 1, or go down 2 and back 1. And then there is your line for this one. My second one starts at negative 2. It also has a slope of 2, so that says go up 2 and right 1, or go down 2 and back 1. If you didn't see it from the equations, you'll for sure see it when you graph it, that these two lines happen to be parallel, and so that would mean that there is no solution here. So again, it was easy for us to graph these, and it was beneficial because from graphing, we could easily see that there was no solution to this systems. When we look at word problems, we want to write them first, and then after we write them, we can determine which one is best to solve with. So a group invested $20,440 into 2 accounts. A secure bond account earned 2.5% interest, and a more risky stock venture earned 3.4% interest. The group earned $623.05 for the investment in 1 year. How much did the group invest into each account? So we're looking for the amount invested in each account. So Y would be the amount in the secure bond, and Y would be the amount in the risky stock. Now we have two totals. Our two totals are $20,440 and $623.05. My first equation, since that's talking about the total amount invested in the 2 accounts, would be x plus y is equal to $20,440. The amount invested in the secure bond plus the amount invested in the risky stock equals $20,440. The second one would have to do with the interest rates. So 0.025x plus 0.034y is equal to 623.05. Now because both of these are in standard form, the method that I would use to solve these would be elimination. It would be a little bit easier for us than if we were to use substitution, and a lot easier for us if we were to use graphing, because it's going to be really difficult to graph the slope with decimals. So remember, with elimination, I need to choose one of the variables to eliminate. And this one, it doesn't really matter which one I choose. I just want to get rid of maybe the larger decimal, so I'm going to multiply everything by 0.034y, or by negative 0.034, so that I can get rid of the y's. My top equation is going to change, so it's going to become negative 0.34x minus 0.034y is equal to, and then the only calculation I need to do here is multiplying the decimal to, which gives me 694.96. My bottom equation hasn't changed, so I still have 0.025x plus 0.034y equals 623.05. I combine, so this is going to change. The bottom one's going to when I combine these, the x's is going to become negative 0.009x. The y's, remember, cancel out because now they're opposites, and my total would become 71.91. I divide everything by negative 0.00, and this is negative 71.91. So divide everything by negative 0.009. These decimals are tripping me up. Divide everything by 0.009. Okay, so when I do that, I I get x is equal to 7,990. So that's the amount invested in the secure. To get the other amount, I'm going to just use that first equation. So 7,990 plus y equals 20,440. Subtract 7,990 from both. And I get y is equal to 12,450. So I know the amount invested in the risky stock was 12,450. Again, you want to check both just to make sure that you did it correctly, and then make sure that you write the solution in the context of that problem. Before watching the next video, I would like for you to consider the following. To determine which method is best to solve a systems, what do you look for?